Hello, Brian Biebel here with Teledyne API. Today we will be showing you how to calibrate the mass flow controllers, or MFCs, in our 700 series gas dilution systems running our NumaView software. Our 700 series can be equipped with up to 3 MFCs, with 2 of those being gas MFCs. The choice of MFC ranges can provide customers with a wide range of dilution options. To view the options available, as well as our different models of gas dilution systems, please visit teledyne-api.com. Okay, we've got a Teledyne T750U here. This is our portable gas dilution calibrator, designed mostly around auditing for ambient air quality sites. You can outfit this several different ways, and all of those options are available on our website. This particular one, being a U model, has an ozone fractionator in its generator, which allows us to get down to single ppb levels of ozone very precisely. It's also got the photometer bench option. It's the same photometer that we use in our T400. In that application, it's an FEM, Federal Equivalent Method, ozone monitor. We've got 3 mass flow controllers in this unit. We've got a 10 standard liter per minute dilution mass flow controller, and then we've got 2 gas MFCs, a 200 cc and a 20 cc. That gives us a very big range of gas flows that we're able to blend with our zero air to get a large dynamic range output from our gas concentrations. One of the key things that we have to do with this instrument is maintaining the calibration of those mass flow controllers. Typically that's going to be something that we're going to do on a quarterly or semi-annual basis, where we at least bring in a flow transfer standard, connect it up to this, and verify or adjust the mass flow controller calibrations. So when we get this instrument, there's going to be 2 screws in this front cover. Pop those screws out, and this cover is magnetically caught or captured here. It's going to hinge open, and you're going to see inside here the 3 mass flow controllers. So starting in the front is our 20 liter mass flow controller. The next one would be, I believe this is going to be our 200 cc mass flow controller, and then our 3rd mass flow controller, Cal 2 we call it. In this case is a 20 cc mass flow controller. The flow in this is all from left to right, so our air and gas all come in on the left side here, and they exit on the right side. When I'm performing a calibration on these mass flow controllers, I prefer to make my measurement right at the output of the flow controllers. Zoom in a little bit here. The reason is that if there was a leak in the instrument, I wouldn't want to calibrate with that leak in there. I would want to calibrate right at the mass flow controllers, and that way I know that at least the calibration of those is just as accurate as possible. So you can see down there, since the gas going through these the gas MFCs is the same, there's a T on the input and a T on the output. So this single gas port comes in and goes in, feeds both of these gas mass flow controllers, and then they blend back together on the outside or output. When we go ahead and start doing our calibration, what we'll do, if we can see in here, I'm going to come in. The air, you can always tell on this one, it's going to have a 1/4 inch swage lock fitting in there. We'll spin that out of the way and just push it to the side. Now we're going to grab our tube that's going to our flow transfer standard, and we're going to route it in here. It's a little tight, but it's manageable. Remember, this isn't something we're doing all the time. Use caution about where your hands are. Most everything is electrically safe in here, but it's good to do this and just keep an eye on things. If you're concerned, you could always power this down and unplug it, but if you do that, when you turn it back on, let it warm up for a while, make sure everything's stabilized. If it's a brief power interruption, once it's fully booted back up, you'd probably be okay in 10 or 15 minutes. You could bring out 3 tubes at the same time, and that way you don't have to power it down once. So we've got that connected in there. It's solid, not too tight. We can hinge this back down. Alright, so connected to the other end of that tube that we hook to our air MFC output, we're using in this case a BIOS definer model 220H. This is a graphite piston that moves up and down in a glass pistons or glass cylinder here, and based off the time of flight of that piston, this calculates flow. Now that's a volumetric flow. The device has a temperature and pressure sensor in it, so we can get standard flow or volumetric flow out of this device. In the case of the Teledyne, we want to be calibrating in standard flow mode. So I'll see if I can get in here and show you how this works. But when we turn this on, I always want to verify this when I first turn it on. So the first thing we see is measure and setup. So if we go over to setup and we go to our readings, you can see that's in standard. That's what we want, not volumetric. So we know that we're in standard mode. And then we want to check our units. When these come back from Mesa Labs, they're almost always going to have this standard temperature set to 21.1. Now in the monitoring world we use 25°C, so make sure that you've saved that, adjusted it, and then confirm if you make a change, and then we'll go back to the main screen. Now I'm going to run this remotely. If you're running it manually, when you get your flow in there and get it started, you just go to measure, you decide if you want single, continuous, or burst mode, and that's that. Okay, so we've got the NumaView remote software up here for the T750U, and I've got the DryCal Pro software set up here for the BIOS Definer 220 that I'm going to be using. So the goal here today is to calibrate the 3 mass flow controllers inside of a T750U. The process is going to be the same for a T750 or a T700 or a T700U in NumaView. So this screen that you see for the NumaView is going to be exactly the same as the front panel, and the procedures are going to be the same. The option is that you may have only one or you may have 2 of the gas mass flow controllers in there. So to start out with, I'm going to go ahead and clear this screen on this setup. Now in my DryCal setup, I've got this as software controlled, so I'm going to be actually getting the readings and controlling the BIOS remotely. Now AliCat, any of these mass flow, or many of these flow standard companies are going to offer some kind of remote control software, and especially for this video it's very nice. But even in a calibration situation, by running the software to control that, you've got a log or a record that you could actually capture and keep for showing the calibration of your mass flow controllers. So in this case, I'm running the software or the control through the software. I'm using the burst mode, so I'm going to take 10 averages from the piston meter, and I'm going to average those in for my reading. So when we go over to our data here, first thing we want to do is go into our diagnostics menu under here. We're going to do our dilution flow controller. Now by default, you're going to have a slope of 1 and an offset of 0 here. That means that no slope and offset correction are being applied to that mass flow controller. We're only applying the settings in this table. So in the table, we'll have 20 different set points or targets. These are the drive voltages to the mass flow controller, and this is the flow that we're going to enter in. So we're telling that mass flow controller that when it's sending 1/4 of a volt to the drive or the set point on the mass flow controller, that it's equaling this flow. And this flow is what we're going to measure on our BIOS and enter in here. So if I enable this flow right now, that should check. It doesn't for some reason. But when I come over here, now that I'm highlighted over this 250 millivolt, this is the flow that's active right now. So the T750U software is applying that 1/4 volt signal to the mass flow controller, and I can hear the flow coming out. Now when I come down and I hit get flow on my software here, we're going to see, if we were looking at our meter, that the piston's actually rising right now, and we're going to get a reading. So that's the first reading, and our average is of course the same since we only have one sample there. As soon as I get a couple of sample points, we'll see a graph form over here. That graph can be saved. It's a really nice documentation trail for this calibration. I usually recommend calibrating or at least checking your mass flow controllers on a quarterly basis. Whether you do it quarterly, monthly, annually, semi-annually, it's really nice to get this documentation of these points. So you'll see here that we're actually rising throughout this. What I usually look for is more of an up and down pattern, so that's where the graphing is really nice. I may take a couple of these 10 burst readings until I'm sure that the mass flow controller is stabilized. anytime you can do this sort of QA QC work with graphical representations, I think you're going to find you get a lot better results. And you see it's not a big range here. We started off at 494 and our high point's 510. For our air, that's pretty insignificant. For gases, that would be a big difference. So let's go ahead and run this again. And the best procedure for these points is to wait about a minute after you start each point. That's going to give you the longest, enough time for that to settle down. But when we're doing 3 mass flow controllers and 20 points apiece, the minute or two to let each point stabilize and then taking the readings, you got to give yourself enough time for that. So plan on a few hours easily to take care of all those points. See, this is getting a lot better here, so probably after this batch I'll go ahead and clear out my buffer here and start from scratch. Because right now we've added all of these points into our readings, even though we're in a burst mode of 10. Because I haven't reset this, we've got, we're going to have 20 samples in here. More isn't necessarily bad, but we just want to have a nice stable reading. So now we're starting to level out here. You can see the difference. That should be it. So let's go ahead and clear this out. We're not going to save that, and I'm going to start over with a batch of 10. This is more typical of what I want. I don't want to see a climbing or a dropping curve over time. I want to see just the noise of the measurement here. And what we're after is the average reading. So those are each point. The average is smoothing out over time. So you can see the red is really the noise, and the blue is the rolling average that improves as we go along. So that's the thing we want. Now what we want to enter is the standard flow reading of this whole setup. So our flow average here, I'm going to verify it on the front. I've already got the BIOS set to standard flow. So now up here we're going to go edit table, and we're going to put this reading in here in liters per minute. This is cc's per minute, so we're just going to drop that by 1,000. So we're going to put in 0.518 there. So now we've calibrated this first point. We'll switch over and we'll wait about a minute or so. I'm going to clear this out down here. The way that the 700s work when we're using this table is that if you ask for a point in between these two, it interpolates between them. So say this was perfect and this was 0.500 and this was 1.00. If I asked for, that'd be 750 cc's, then it would exactly be between these 2 points. That's how the system works. So this 750 millivolt calibration point is irrelevant if I'm asking for anything in the range between this 250 and 500 millivolt range. So each point needs to be really accurate. We only, for every point we ask for, we only get 2 of these that actually define our calibration for that target. So anyway, take your time and make sure that you're really comfortable that each one of these points are accurate. And on to the next. Alright, looks pretty good again. 10.888. Okay, so we've gone through all of these. We want to make sure we hit apply so that they're saved. And then if we click off, now you see the check mark, so there's the bug I was talking about, but you can hear in the background that those flows have all dropped off. And all of these points are now in here. So we can go done. And we would move on and do these the same way. Alright, well hopefully you can see that it's a pretty straightforward procedure to calibrate the flows for each of the mass flow controllers. We've gone through how to do that for the dilution MFC. It's the same exact procedure for the gas MFCs, whether you have one or two. Just step through those same 20 points, make sure you use the appropriate transfer flow standard, and please let us know if you have any questions or concerns.